Hey, hello everyone. Welcome to Microsoft Data and AI South Florida user group. We are so happy to be here again with Haripriya Naidu today. She's going to talk about how to fast load SQL tables with couple of tips for us today. So I'm so honored to be here moderating this session. So if you have any questions, please do not hesitate to put in the chat window. I'll be moderating the chat window and I'll ask Haripriya to for her answers in the meanwhile as she speaks. So if you like this video, please give a like button and subscribe to our channel. So without any further ado, I will go ahead and um, hand it over to Haripriya.
Hi, hello everyone. Let me share my screen. Okay, so do you all see my screen? Yeah, probably the theory channel. You can just put it in there if you can. I'm sharing my screen. If you can just see it. Okay.
Okay, maybe yeah.
All right. Do you see my screen? Okay, that's good. Hello everyone. Thanks for joining. Today's session will be about how to load data faster using the tab lock hint. Let me get this. And about myself, this is Haripriya. I've been working as a SQL Server database administrator for 11 years now. I'm very passionate about databases. I love diving into the internals of the SQL Server engine, and performance tuning has always been intriguing for me. And I actually started my speaking journey with New Stars of Data 2024. And then I spoke at a few SQL Saturdays in Boston, San Diego, and Albany, New York. And also I spoke at Past Summit in Seattle. So that's about my speaking journey. And I won a couple awards at work. For last year, it was Rookie of the Year, which I got in 24 for the work I did in 23. And then this year, it's kind of a different and an encouraging award, especially to read books, because I was just reading a lot of books, I guess. I read about like 11 and a half books last year for a period of 12 months. And then also I was continuously learning both the technical stuff and, other things. So I got that award bookworm award just a couple weeks ago. So that's about me. And just checking, so you can all hear me, right? All right. I hope you can. If not, just put it in the group chat. All right. And agenda for today. So I will be talking about, and I'll be showing demos on how to load data faster using the tab lock hint. Like we will see the demos across user tables and in temp tables for different recovery models, and if it works on tables with indexes. So we will see different types of things where tab lock hint works the best and also where it does not work properly. So all those things. And it will be a fully demo-based session. And I'll be talking less with PPTs, but I will still be doing demos. And this is of level 300, kind of an intermediate level session. It's good if you kind of know the basics of how to read the execution plan and like what a transaction log is and, to query the log. I can show you all that stuff, but it will be very helpful for you and you can understand better if you already know the basics. And I specifically want to mention that this session is not about different ways to load data, or it is not about what is the best way to load data. All right. So this is only about the tab lock hint, like how to load data faster using this hint and when to use it and when not to use it. So that's what I will be talking about. All right. Want to make that clear. It's not about the different ways and what's the best way. It's none of that debate. All right. Okay. All right. So what is the problem I'm trying to solve here? Little background. I was working on this project where a table had 40 billion records, and I have to move a big chunk of it to another table, kind of stage that data, and then process it for like an analysis, like a quality analysis with compared to the other data. So all that, let's leave all that aside. So the part that I'm focusing here is, move that big chunk from one table to the other table. So to move almost like 20 plus billion rows, and then I was trying different types of different methods to insert the data, and everything took forever, like hours, to do all of that. And then I recalled, like when I was posting on LinkedIn about a few other things about inserts and things like that. One of my other team members reached out and said, "Hey, have you tried the tab lock hint?" And I'm like, "No, I haven't tried that." And then I was like, "Okay, fine." And then I went and tried things out, and then I was amazed to see, like you won't even believe me, when I tried with the tab lock hint, it made the run 5 to 6 times faster. I'm like, oh my God, this is great. Well, a disclaimer here. It has to be used under the right set of conditions. This does not work for all the inserts. I'll be explaining that in the demos. So back to the story. So when I used the tab lock hint, the performance of that insert operation was great. I was able to get done things very quick because of that. And then I started digging deeper, like how is this helping? Like why is this tab lock running faster? I mean, the insert is running faster with the help of tab lock. So I did a lot of research on that and ended up writing a couple articles about it because I felt like, oh my God, this is useful. So I wrote a couple articles about it. And then Brent Ozar, he added those blogs in his newsletters, and he told people to subscribe and also read those blogs. And the feedback I got from that was from a few people that it was very helpful for them, and they have been in those situations too where this could have helped. So that's when I decided, okay, then I'll do a session, I'll do a demo and people can watch it, and probably it will help even more people. So that's how I came up with, okay, I want to talk about this tab lock hint and do the demos and, solve the problems for people, whoever has these, insert for archival or insertion to stage data, anything of that sort. All right. So what is that so good about tab lock hint? Two main things. When you do a regular insert operation, imagine you're inserting 1,000 rows. In the transaction log file, all that 1,000 entries will be recorded. And that is called fully logged, like everything is logged, right? But when you do the insert operation with the tab lock hint and you are inserting 1,000 rows, not all of that will be recorded in the transaction log. Like if you're doing 1,000 rows, you will not see all that 1,000 entries in the log file. You will see probably 0 entries or sometimes just a few entries, like 5, 10 entries, and that's it. And that is called minimally logged. The difference between fully logged and minimally logged is you save a lot of time because the operation doesn't have to keep writing everything to the log file. So you're saving a lot of time. And that is what is helping the insert run faster with tab lock hint. All right, so that is one part. The second part is the parallel operation. When you take a regular insert operation, it is always serial, no matter what. Even if that operator cost is more than the cost threshold of parallelism, that regular insert will always be serial. All right? Which means serial means only one thread is inserting data into the table. But when you do the insert with the tab lock hint, what happens is, especially when the operator cost is more than the cost threshold for parallelism, you have multiple threads inserting that data into the table. So if you have 1,000 rows, you'll have 7 or 8 threads inserting 150 each or 120 each. So imagine at the same time you have multiple threads inserting data for that insert operation, then again, the execution time is faster. So these are the two main important things that will make the insert faster because of this tab lock hint. And again, disclaimer, this does not work for every insert. it will work only under the right set of conditions, which I will show in the demo. All right. Any questions? All right. I'll just go to the demo. Okay, so you can hear me all right and no questions for now. All good. And I will be making pauses in between, if you have any questions, or you can just post it in the chat here and I can address them. Let's go to the demo for now. I'm going to bring up my SSMS. So what I'm going to be doing is, I'll bring this Excel sheet here. So what I'm going to be doing is, I'm going to be inserting 1 million rows into a target table and then do a regular insert without the hint. And we will note down what the runtime is. Did it run serial or parallel? And did it do minimal logging or full logging? All right. And similarly, I will compare that with the insert. Now I will add the hint and then record the metrics. So for different set of conditions, like for different recovery models and for different indexes, I'll be doing all of this and then I will write down the numbers. So at the end, it will be easy for you to visually look at it and go like, oh, okay, I think, yeah, for this, it works good. For this, no, I'm not using the hint. So you can make that clear decision. All right. So first thing, now let's go ahead and do the insert without the hint and note down. Okay, so I'm going to be using this DBA test database, and T1 is our source table, and it has million records already on it. I've loaded it, and then T2 will be a target table, and it has 0 rows on it. So T1 is our source table having million rows, and T2 is a target table having 0 rows. What we are going to do is insert into T2 from T1. I'm going to show this here. But before that, let me turn on this stats and time so we can get the perfect idea of the execution. And I'm also issuing a checkpoint here. Let me just give you a quick explanation about checkpoint. So when a checkpoint is issued, it will write everything from the log file from memory to the disk, which also means it will truncate the log, like clear out the transaction log file. And in simple recovery model, just a checkpoint will clear out the log. But in bulk logged and full recovery model, you have to do the checkpoint and also do a T-log backup. All right, let's not go into too much details. The reason I have checkpoint here is I just want to clear out the log, have a clean slate. So whatever I do now, I can check if that log is fully logged or minimally logged, and we can do that analysis. All right. And my database is right now in simple recovery model. All right, and I have the execution plan turned on. I'm going to do just a regular insert without any hint here. Okay, so let's go and run this and see how many seconds it's going to take. So that is inserting million rows from T1 to T2. And if I scroll down, okay, I see this here, 4.8 seconds. So let me note that down here. We have 4.8 seconds. All right. And we are going to check for parallelism or serial operation. Like I said, a regular insert is always a serial operation no matter what. And if you see this, this is the insert operator, and you don't see those yellow parallel lines. Only if you see those yellow parallel lines, it is parallel operation. It's just you don't see it, so it's serial. And I'm going to do the properties. Also show you one more thing here. You can check the actual number of rows. You see 1 million rows, but it's just one thread. And that also means it's serial. All right. So it's a serial operation. Let me also just quickly note this down here. And now I'm going to check how much of it is logged in the transaction log. So we did an insertion for 1 million rows. Because this is a regular insert, you will see all that 1 million rows having entries in the transaction log. Means all of that is tracked in the transaction log. All right. And how do we find that out? There is a function called fndb log. We can query that using these two operations. Log insert rows means log operation for insert rows. If you check that, that will tell you what insert rows are tracked in the transaction log. And log format pages, for this operation, how many pages were formatted. So let me go ahead and do this now. And the expectation is we will see all million records entries in the transaction log file for that log insert rows. Okay, here we go. You see almost more than a million row entries we have, which is as expected. And format pages, 6,500 pages have been formatted. So when you look at this, this is called fully logged. Every row that is inserted has been tracked in the transaction log. So this is called fully logged. So let's just write down here. I'll just write down full. Okay. So this is good. So when we did the regular insert, now we have the numbers. Now let's go ahead and do the insert with the hint, with the tab lock hint, and see how it performs. All right. Here we go. I'm using the same database, and I'm going to truncate the table because we have to reset the environment now. This is the target table. And I will do a checkpoint because I want to just truncate the log. All right. Now let's verify if the log file is clear. Just run that same statement, the query that I used earlier. Okay, you have everything 0. So the log file is cleared. That's great. Let's make sure we have 1 million rows in T1 and then 0 in T2. That's perfect. All right. And we have to enable the stats so we can get those perfect numbers. All right. So like I said, for minimal logging to happen, which will help speed up the execution, just the tab lock hint won't help. There are a few set of requirements that need to be satisfied. All right. First thing being, it must be a heap table. Well, about indexes, I'm going to show you further. But for now, let's see if this is a heap table, the target table. All right. So T2, that's a heap table. Good. And it cannot be part of replication. If it's part of replication, you cannot have minimal logging. Even if you add the tab lock hint, you cannot have minimal logging when it's part of replication. So let's make sure this table is not part of replication. All right, nothing. Good. And now let's check the recovery model. It's simple. Okay. And I will also show you further if it works for other recovery models. So for now, we satisfied these 3 requirements. Now what we can do is add the tab lock hint. So that will make more sense. So you have all the minimal logging requirements. Now add the tab lock. So that will help speed up the execution. So the syntax here is you will write the insert into target table. And before you mention the columns, you write this hint with tab lock. All right. So that's the syntax here. And then this is as usual, select star from the source table. All right. Let me go ahead and run this. And let's see how much time it takes. Okay, if you look at this, just half a second. And how long did we take earlier? 4, like close to 5 seconds. And this one, if you see, it's just half a second. I'm going to note it down here. You see the difference already? Like 10 times faster for a million records. All right, let's check the parallelism. And this insert operation, if you look at this, this is the table insert operator, and you have 2 small yellow parallel lines. Okay, I will not hover over it. You see the 2 yellow parallel lines? So that shows it is a parallel operation. And let me click on this and also show you here in the properties. You see for these million rows, you have 7 threads inserting data. So for this operation, you have 7 threads inserting data parallelly into the table. So that is again helping to run this insert faster. All right. So let's note that down here. It's parallel. And then now let's check the logging. So how is the logging here? Is the logging minimal or full? Earlier we saw it was fully logged, like every inserted record had an entry. When the tab lock hint is there, let's check if you have all the entries recorded in the transaction log. So we will check this FNDB log and for these log insert rows. All right. Okay, so it's just 52. Like compare it with 1 million rows and with 52. It's like absolutely nothing, right? So, and then also if you see the pages, just 3 pages were formatted. Earlier we had close to 6,500 pages formatted. So this one, I will call it minimal logging. Like absolutely, you don't even see that much of logging because of this tab lock hint. So I'm going to write here minimal logging. So you see the difference here. Without the hint, like a regular insert has close to 5 seconds, and this is a serial operation and fully logged. That's why it's taking that much time. But if you see it with the hint, 0.5 second, like 10 times faster. Why? Because you're having a parallel run. Multiple threads are inserting data. Execution time is so quick. And then logging is just minimally logged because it does not need all that time to keep writing to the transaction log file. Yeah, inserted record and then inserted 10th record, all that operation, all that logging is reduced. So minimal logging really, really helps here. So these are the two things, minimal logging and parallelism helps make this insert with the tab lock hint run faster. Any questions? All right. Thank you. Now, whatever we saw was in simple recovery model. What I'm going to be doing now is, let's try this out on the full recovery model. Because on production, you have full recovery model, and you'll be like, yeah, you told us about tab lock hint for simple recovery model. How about, do I use this on production or do I use this on full recovery model? Yes, let's find out answers for those questions. Let's go ahead with the full recovery model here. What I'm going to do is set this database to full recovery model, and then just verify if it's in full. That's good. I'm going to truncate the table, the target table, and then just clear out the log and just verify how the log looks like. Okay, it's clean. So when we do the insert now, we can have a clean slate to check how the logging is. Let's verify the row counts. T1 has million rows, T2 has 0. That's good. And I'll just enable the stats and turn on the no count. Okay. Now I'm going to do this insert operation. So the only change we did is we have full recovery model and we are checking the insert with the tab lock hint. Let's go ahead and run this and see how long it takes. Okay, this is good. It's just 300 milliseconds. All right, so it's even better. All right, and then let's also check the parallelism. Again, if you see, it has two parallel lines, operation. And if you check in the properties here, you see multiple threads doing it in parallel. So that explains why it ran faster. And also, let's check this logging. If it's minimally logged, I'm sure it must be minimally logged, and that's why it ran this fast. All right. Okay, so here if you see, for inserting all those million rows, nothing have been tracked in the transaction log, which helped it run faster. But the only thing that you see is the formatting of pages, which are 6,500 pages. So this, I won't call it completely minimally logged. I will call it efficiently logged. This is not fully logged either because you don't have that million entries in the transaction log file being tracked, right? So it's not fully logged. And at the same time, because the pages are formatted here, I will not call it minimally logged. Let's put it as efficiently logged. It still runs fast, but it does a little bit of logging. All right. So this still went parallel, and then I could call it efficient, right? So this is also great. Okay, so this is good. So that explains you can use this tab lock hint for inserts on your simple recovery model, bulk logged, and full recovery model. Bulk logged recovery model with this hint behaves the same as simple recovery model. That's why I did not do the demo, but you can check it out. Simple and bulk logged behaves the same with this hint. Full recovery model is where we have the question because everything gets logged in full recovery model, right? So you can use this hint in simple, bulk logged, and full recovery model. All right. This is good. We checked on a table that has no indexes. This T2 target table, it's just a heap table. Heap table means it has no indexes. How about you already have an index on this table, like a clustered index? Does this hint still help? Let's find out. Right. with hint. All right, so we are going to do on clustered index, non-clustered index, and column store index, and we will see where you can use this hint and where you have to really avoid this hint and it's of no help. All right, like we discussed previously, I'm going to truncate the target table and clear the log. Make this also, I just want to quickly check. I just want to put this database to simple recovery model back. All right, that's good. So I just truncated the table and then issued a checkpoint to clear the log. Let's check if the log is clean. That's good. I don't see anything. And let's also double check the recovery model. It's in simple. All right. And I just want to enable the stats so you can get these good numbers. Execution plan is on. That's good. Let's verify the target table and the source table. Good. Source has million rows and T2 has 0. That's good. Now what I'm going to do is create the clustered index on this table. All right. On the target table. And then now do the insert into the target table with tab lock. So this table has clustered index. So let's go ahead and run this. Let's see how long it takes. Okay. So this took close to 1.6 seconds. All right. And let's check the execution plan. And if you see, this is the clustered index insert operator, the one I highlighted. That, if you see, is serial. It's not parallel. Remaining operators have run in parallel, but the insert did not run in parallel. That is because whenever you have an index, that means, especially with the clustered index, that means the table is sorted. On a sorted table, you cannot have multiple threads inserting data into different places. You can only have one thread inserting data into a sorted table. And that's the reason with indexes, you cannot have multiple threads inserting data in parallel. So that's the reason this is serial operation. Also, if you check the properties of this, you see how only one thread inserted all that million rows. All right. So for clustered index, let's note down, this is 1.6 seconds. Oops, I did 106. No, 1.6, and this one is serial, and this one, okay, let's check the logging. How much did it log in the transaction file? Okay, so this is minimally logged, like absolutely nothing. This is good, right? But what I want to show you is, don't get deceived by this cluster index. It can be very deceiving because that's what it happened to me too. I was like, oh wow, this is great, so I can use it on clustered index. No, this works good when you have an empty target table. All right. When the target table is already loaded, it does not work fine at all. Clustered index, when you have a clustered index on a table, it's not a good place to use the hint. I'll show you in a second now. So what I'm going to do is run this insert again, but this time with both the tables having a million rows in it. So earlier, what we did was target table had 0. It was a empty table. But this time I have both the table with data in them. And now I'm going to run the insert with tab lock hint. So the change here is target table still has the clustered index and target table is not empty. And let's see how it performs. This will take a few seconds and let's see how long. See, already if you see, it's like more than 6 seconds, 7 seconds. Wow, it's just, okay. So if you see this, almost 8.5 seconds. So I just want to note this down here. So that's the reason I wanted to show you how this runs when the target table is already loaded. This does not happen to any other things that we just talked about, but with the clustered index, this hint is not a good place to use. I don't think it is going to cause any harm, but it's not going to help you at all. There's no use of having this tab lock hint. It's because when you have an index, clustered or non-clustered index, it's only going to be a serial operation. The biggest advantage of tab lock is parallel operation, minimal logging. But in this case, you're missing the parallel operation. So it's just a waste of time to add the hint. You could just do a regular insert operation. Or if you still want it, you could disable or remove the clustered index do the insert with tab lock. When it's done, you can put the index back. That's just one of the solutions. You could try on your lower environment, see how things go. But if you already have the index and if you don't want to remove it at all, please do not use tab lock hint on the target table where there is a clustered index. All right. Now let's check what if a non-clustered index exists. Will the results be the same? Let's check it out. I'm going to drop the clustered index that I had created, and then I'm going to truncate the target table. It's just taking a few seconds. Usually it doesn't take this long, but I'm guessing it's because of the streaming too. Maybe I don't know if it's slow, but okay, all right. And then I'm going to clear out the log. Now I'm going to go ahead and create the clustered index on T2, which is an empty table. And then let's just verify the row count. So T1 source table has million rows, and then T2 has 0. That's good. Now I'm going to do the insert with the tab lock hint. So here, the only changes, target table has non-clustered index. It doesn't have any other indexes, just a non-clustered index, and it is empty right now. So we are doing the insertion. Let's see how it performs. And if you see, so I think this is going to take a few seconds too, right? Looks like it. It's already 7, 8. Okay, here we go. We have 8.5 seconds. So you just know this is not good. Yeah, it's fine. We're not going to worry about it. Let's see. Why am I doing 0 all the time? Okay, so this is taking 8.5 seconds. It's no good. And if you check the insertion, it's all serial operation because you have the non-clustered index, so it's not going to get parallel. So that's okay. And I'm not going to check the logging. Minimal, it will still have, I mean, I don't mind if it's minimal or full logging because the moment I see it with 8.5 seconds in serial, I don't think it's going to help out. All right. So with the tab lock hint, I will really suggest not to use it when you already have clustered indexes or non-clustered indexes on the table. All right. Any questions? Okay, so there is a question. Wouldn't drop the index, populate the table, and recreate the index be more efficient? Yeah, you can do that too. That's one of the solutions that I just mentioned. So if you really want to get this insert run faster, you can remove the index, do this insertion with the tab lock hint, and put the index back. Yes. Oh, that's one of the good solutions that we can use. Yes. All right. Any more questions? Yeah, you can just post them in the chat and I'll address them. All right. So we took a look at 2 of those indexes. Now let's take a look at the third one. This is a different type of index, a column store clustered index. Let's see how it works with the column store clustered index. Whatever we saw now were row store, like in our OLTP daily lives, what we see is the clustered and non-clustered index we talked about. Now let's try it on column store clustered index. So I'm going to remove the non-clustered index that already existed on the table. And I will also truncate the target table, clear out the log. And then now I'm going to create the clustered column store index. And let's check the row count just to make sure. Good, million rows and target is 0. That's good. And let's do an insert with tab lock. So this insert with tab lock, the change we have here is target table is empty and all it has is a column store index. And let's see how tab lock performs when there is a column store index. All right. Oh, wow, this was quick. Okay. So just 700 milliseconds. Awesome. Execution plan. Look at this. This is parallel. Isn't that good? And if you see this actual number of rows, you'll have multiple threads inserted. So that's great, right? So that explains why you have this insert run in less than a second. It's because it is parallel. Well, we will also check the logging, but for now, you have a parallel operation. So that's the difference between the row store index and the column store index. So you can definitely use this tab lock hint with this column store index because it is able to run in parallel. This index structure is different from what we have with the other indexes, like the row store index. So that's why it's able to take this parallel operation, like multiple threads inserting data into this table. And this column store index is usually very, very helpful in analytical queries like analytical tables, reporting, for all those things, especially for OLAP. They use this a lot, not on OLTP though. On OLAP, this is very helpful when you want to do bulk inserts, huge amounts of data. So now you can see this insert with tab lock on a column stored index is very useful. All right. So let's note this down here too. What was this? 0.7 seconds, right? Yeah, 0.7 second. And this one we saw it was parallel. That's great. Let's also check how did it do the logging. Is it minimum logging or fully logged? Okay, that's like nothing. Just 80 entries were there and then just 2 pages were formatted. So let's write down this as minimal logging. So what do you see from here? Let me do it like this. Okay, so what do we see from here? Insert with the hint on a simple recovery model is great. Full recovery model is also great. So let me just slightly kind of color this so we can talk about it. So these two things are great. Clustered index and non-clustered index, no, just stay away from it. Don't use the tab lock hint on clustered or non-clustered indexes. Just use it on a heap table because you can see. Use it on a heap table. Use it on simple recovery model, bulk logged or full recovery model, and also use it on a table that has column store index because you can clearly see from here the benefits of it. Because what we want is when you see parallelism and when you see minimal logging, this hint is going to help because that's what this hint is all about. It runs faster because of parallel operation and because of minimal or efficient logging. All right. So the 3 places that I would use this hint is simple recovery model, bulk logged, full recovery model, heap tables, or tables with column store indexes. All right. So this is great. Okay. So you're using it in the user tables and we observe the differences and we know where to use it and where not to use it. All this is good. All right. I have my stored procedures and I have temp tables, inserting data into that temp table to stage the data and then process it. Can I use it on temp tables? Let's check it out. Let's see if you can really use this on temp table, if this hint is going to help. If this hint helps in temp table, you can add this in the stored procedure. And you can imagine when it improves the runtime for inserting into the temp table, which automatically improves your stored procedure runtime. Wouldn't that be awesome, right? Let's check it out. All right, so we did this one. That's good. Let me get this. All right, so let's try it out with the temp tables. Same database. I'll just clear out the log, truncate it, and then, okay, I'm going to create a target table, ash T2. So that's a temp table. And then I will use the same source table, T1, which has million rows in it. And I'm going to use a new temp table, which I just created, and it has no data in it. So it will have 0 rows. I don't know why it takes so long to just return a count. But anyways, so the source table has million rows and the new temp table has 0 rows. What we are going to do here is I will just check the insert into the temp table, inserting into the temp table, select start from T1, the source table. I will run this insert without the tab lock hint first. Let's see how long it takes, and then we will run with the hint. Because you cannot compare the metrics with user table to temp table. That's why I want to compare with temp table to temp table. So I will run this first without the hint and record the numbers. All right. So, okay, so it took 1.2 seconds. I'm going to note this down. And then did it do parallelism? No, because it's a regular insert statement. It will never go in parallel. It's just a serial operation. You don't see those yellow lines. So I'm going to write here serial. All right. Okay, so what helped it run fast? Let's see if it's minimally logged or fully logged. If you see this, nothing was recorded in the transaction log. So let's put it as minimal. That's good. Okay, now you know the numbers, how it performed without the hint. Now I'm going to run this insert with the hint and see how it does. All right. So let me reset the environment, truncate the table, Make sure it has 0 rows. Good. And then just truncate the log. Now I'm going to do the insert with the tab lock hint. So the only change here is I'm doing the insert with tab lock hint on a temp table. All that we were doing right now, before this, was on just regular user tables across different recovery models and indexes. This one is on a temp table. All right. We are testing the tab lock hint on a temp table. Let's see how it runs. Okay, that was quick. 0.3 seconds. All right. So this is good, isn't it? Like almost, again, you see this almost 10 times. Oh, no, sorry, not 10 times faster, like 4 times faster. Yes. And let's check if it ran in parallel. Yes. You see this table insert operator having 2 yellow parallel lines here. It ran in parallel. And I also checked the threads. You see all these threads here. Isn't that great? Awesome. So let's write this here too, that it ran in parallel. So that helped the insert make it faster. And let's also check the logging. And the expectation is it should be minimal. Okay, good. Did not write anything to the log file. That's great. Okay, so now if you see this hint also works on temp tables, because you could see it's just less than half a second for what it took, like more than a second. It is only 0.3 second, and then it ran in parallel, and then it is also minimally logged. All right. So if you look at this, the places where we can use this hint, let me do it like this. Yeah. So now exactly you can see the numbers and decide for yourself where you can use this hint. On temp tables, on regular user tables, simple recovery model, full and bulk log recovery models, and for indexes only on column store indexes. Don't use it on clustered or non-clustered indexes. All right, this is great. Okay, I've been talking about tab lock hint and I've been praising about it. But what about its locking behavior? How much it is locking the table? We have to find that out, right? Because you don't want to do this on production and lock the whole table and have blocking going on. And people are going to be pinging you left and right. Hey, I have this table blocked. Did you do something? Yeah, let's avoid all those pings and extra questions. We'll take a look at the locking behavior here. This is not logging that I'm talking about. I'm going to show you the locking, L-O-C-K locking, okay? I know there are just too many terms that get confused. All right, let me show you the locks here. How is the locking different from a regular insert statement and when you add the tab lock hint to the insert statement? All right, so it's the same database. I'm just creating a new table called dbo.testLog, just a simple table to test the logs. And what I'm going to do is insert some random data into this test log table. All right, without the hint. This is just a regular table. So for now, I'm just going to load it with initial data. I'll just do the initial data. And also let's just verify the logs. We shouldn't have anything. I'm just checking the environment before we go ahead. We don't have anything, but the only thing that you have here is a shared log on the database. Whenever you open a SSMS window like this, you will automatically have a shared log on the database. If I were to open another tab, then you will see with that split and you will see a log. So that will happen to any window that you open. So we don't have to worry about it. All right. Now comes the real thing. Here, I'm going to insert the data without the hint. I'm going to do a regular insert. But what I'm going to do here is I'll just do begin tran and not commit it. I'm not committing it at all because I want to see what logs it has acquired. All right. So let me do this insert. 2000 rows inserted. Good. And I have not committed it yet. So I can check the logs. If you see this here, you see how it has exclusive logs on all the keys, almost close to 2000 rows. It has exclusive log on the keys. Fine, let me explain you this. So this DM tran logs will give you what object has what log. What SPID has what log on the object. All right. So this is the 59 session ID that we are running. And it has been granted an exclusive lock on this key. So that's what you are seeing throughout here. So the insert, the regular insert that we ran now, has been granted an exclusive lock on these keys, on these 2000 keys that we did the insert. This is granular level of locking. So the first level is the key level. The lowest is the key, and then the page, and then the table. So, there are multiple locks, but this is like, it has just got the granular level of locking. All right. What I'm going to do now is, so I showed you this, right? It has like 2000 plus exclusive locks on the key level. So this is granular level locking. And now I'm going to just do a rollback. All right. So we checked this on an insert, on a regular insert statement. Now what I'm going to do is, I'm going to do an insert with the tab lock hint and see how the locks are now. All right. Let me do this. And then now I'm going to check the logs using the DM tran logs DMV. This will give me what logs are present now. You see this? You see the difference here? We did the insert with the tab lock hint. What it did is it got an exclusive log. X means exclusive log on the object itself, like on that whole object test log. It just got an exclusive log. This is a higher level of locking. In a regular insert statement, you saw it had granular locking, like at the key level. It was just getting a lock on every key. But with the tab lock hint, it just got a lock on the whole object. So when it has a lock on the whole object, no other operations can perform anything on that table, which means you're causing blocking. So never use this tab lock hint on an OLTP system, like on a table that is highly volatile. Means a table that has data constantly changing. When multiple operations are constantly changing the data into the table, never use tab lock hint on that table, like OLTP systems. Or when concurrency is very important, which means multiple operations need to keep accessing that table, don't use tab lock hint, because as you see, it will take an exclusive lock on that whole table. Blocking will happen and you cannot have multiple operations access the table. So it is very important you use this tab lock hint with care, because I just don't want to show you just the power of this hint. I also want to show you where you should not be using, because whenever I try to learn something, first thing I look at is where I shouldn't be using this. That's more important than knowing where I can use this. So that's why I wanted to show you this. Tab lock hint gets an exclusive lock on the object. So never use it on a table where you have multiple operations constantly talking to that table. Don't use it on it. Rather, you could use it on like OLAP tables, for the table that needs huge amount of data insertion and it's for staging or processing, and that table does not have multiple operations talking to it all the time. You can use it on those tables. You can use it on temp tables, right? Temp tables, there are not many talking to it. It's just one temp table, one operation, right? You can use it on temp tables on your stored procedures. That's a good place to use, because temp table can be locked, no problem, because at one time you're only doing one thing to a temp table. You can use it on temp tables in your stored procedures. You can use it on a table, for example, like an archival table. You want to get all the data from, for example, from orders table and put it into an archival table, like the old data. That archive table, I don't think anyone's going to be accessing it. And even if they do, it's fine for some time of blocking, as far as I know, because archiving is not, no one's talking to that archival table for long. So, you have to plan accordingly where you can use this tab lock hint. Like I said, one place not to use it is on a busy OLTP table. All right, because you have multiple things talking to it, don't use it on that. Use it on OLAP, temp tables, other staging tables, temp tables, and many other things. They can be extremely useful. The thing is, you have to know that right set of places where you can use them. All right, so that's why importantly I want to show you how this lock acquires. All right, so I'm just going to roll back this one. Any questions? Okay, so what is it? Okay, I have a question. What is the difference between efficient and minimal logging? I believe it is in between fully logged. Yeah, almost in between. So let me bring this spreadsheet back again. So if you see this, you see minimally logged means you have very less number of insert records tracked in the log file. And also you don't have many pages being formatted. Fully logged means you have every single entry tracked and you also have a lot of pages formatted. But for efficiently logged, you don't have all the entries tracked, but just the pages formatted. Like, yeah, you could say it's in between, like minimal, it's more closer towards minimal logging. Like in between, if you take from 1 to 100, if 1 is minimally logged, I would call efficient somewhere like in 30, 40, or 20, like less than 50, if 100 is like full logging. All right, so that's efficiently logged. It is still giving you a fast run. It is running in parallel. It's not logging all million entries, but it's still formatting the pages. So that's why I wrote it's efficiently logged. Hope that helps. Any more questions? All right, okay, thank you. And then, okay, so we looked at all of these, and then, so we talked about clocks. I also want to show you about parallelism. Just because you have a tab lock hint, that doesn't mean the operation is always going to be parallel, meaning multiple threads are not always going to be there inserting data. It still needs to cross that cost threshold for parallelism. Let me show you the demo here. 8, I think. Oops, sorry, not this. Okay, so let me get this. What I want to show here in this is, let me just clear out the log file, and then I'll just truncate the table, preset the environment. Now, I think I have this on. Okay, so let me show you what is the cost threshold for parallelism. The number right now is 5, all right? What I'm going to do now is create this T1 source table just with 10,000 rows. Earlier we had all million rows. Now I'm going to only do 10,000 rows, all right? The reason I'm doing this is I reduced the total count from million to 10,000 because I want to see what the operator cost is. Only if the cost goes beyond 5, you will have parallel operation, even with the tab lock hint. So that's the point I want to bring across, all right? And let me run this insert with the tab lock hint, but this time it has only 10,000 rows. Let's see here. Oh, I didn't remove the clustered columns to clustered index. Just give me a second. This is 6, right? 5. All right. Okay, let me get this out. Just give me a second. I'm going to reset the environment again, just to make sure we are good, because I didn't clear one of the indexes that we demoed earlier. Let's see, T1, T2, this is good. Okay, so what I'm going to do now is run the insert statement with tab lock hint, this time just with 10,000 rows, and see if it goes serial or parallel. All right, okay, look at this. Even with the tab lock hint, it did not go parallel. It just did serial operation. Why? Because if you check the properties of this insert operation, you will see the value is just 0.5. Whereas our cost threshold for parallelism is value 5, right? So only if your operator cost, let me get this again. Okay, so only if your insert operation cost is more than 5, it will do a parallel operation. All right, so in this case, we just have 10,000 rows. Even with the tab lock hint, it will not go parallel because it did not exceed the threshold. All right, now what I want to show is increase the rows by a little bit. Let's see, I'm going to increase it by 90, around 98,000, and see how it is. And let me truncate the target table. Let's check what we have here. So on T1, I have 98,948 rows. And on T2, I just have 0 because it's a target table. Let's do the insert now and see if it crosses 5, it will go parallel. If it doesn't cross 5, it will still be serial. All right. So let's see this. Okay, it's still serial. And let's check the cost. You see the cost here? 4.999. That's the reason I actually tested this out and put that row count there, because I want to show you when the cost is less than 5, it is still in serial operation. You get the idea? Even with tab lock hint, if the cost is less than 5 for that insert, it will still be serial. Now what I'm going to do is just increase this row count by 1 and see if it goes parallel, because at that time it should exceed 5. All right. So let me just increase this by just a row count, just one row, and look at this. Okay, so I just did, we had 98,948. So I just increased one row, 98,949 in the source table, and I'm going to insert it now. Let's see if it goes parallel. Okay, here we go. It did go parallel, and I'm going to check this one here. You see the subtree cost 1.11. That is because it crossed 5 and enabled parallelism. Because it crossed 5, it got parallelism got enabled, and with parallelism the cost is 1.11. So that's how you have to read this. You understand? And I also want to show you what if I were to run this same insert operation with this 98,949 rows without the tab lock hint. You will see the subtree cost little bit more than 5. So let's test that out as well. I'm just going to truncate the target table and I'll show you. So T1 is 98,949, the one which we saw with the hint, it went parallel, right? So here I'm going to do without the hint and show you what the cost is. So if you see this, you see the cost here, 5.00055, a little bit more than 5. Even though the cost crossed the cost threshold for parallelism, it is still in a serial operation. That's because it doesn't have the hint. Like I said, a regular insert operation will always be a serial operation, even if the cost exceeds the threshold. So that's the point I wanted to make here. And when you added the tab lock hint, didn't you just see the cost going down to 1.11? That's because it went more than 5 at that time when we added the hint. So parallelism got enabled, and then the cost became 1.11 when we added the hint. But without the hint, you see it's still more than 5 and you will still have serial operation. So that is about this parallelism. The takeaway from here is, even with the tab lock hint, parallelism will get enabled only if the subtree or the operator cost crosses the threshold. All right. So that will be the end of demos. I will go back to our slide and do a quick recap. So what are the benefits of tab lock hint? There are two extremely good things about this hint. Minimally logged means it almost writes nothing to the log file. That is what is making the run faster. And also parallelism. When you have the cost exceeding that threshold, you have multiple threads inserting data, which also contributes to that faster execution time. So these are the two very, very good things about the tab lock hint. And the locking behavior, you have to be very attentive to this and you have to keep it in the mind, because please don't use it on your OLTP systems, because that's going to cause extreme blocking. And for the regular insert, you always see granular locking, like in the key level, or like, the page level, row level lockings. You don't see table level locking usually. This means you have very less blocking because you have these locks just on the key level. You can have other operations doing their work on the other pages of the table. All right, so that's why you have less blocking with this regular insert. And the lock will escalate to a table level lock or something when it has more than 5,000 locks. I think that's the escalation threshold. But with the tab lock hint, it will lock the whole table in most of the cases, and it will block all the other queries that are trying to access the table. That's why I kept saying, please do not use it on your OLTP or extremely concurrent tables or highly volatile tables where the data is changing. Do not use this hint. So what are the takeaways? You can use this in simple recovery model, bulk logged recovery models, Heap tables, excellent. And then on column store clustered indexes, especially on your OLAP environments. And you can use it on temp tables, on your stored procedures to stage the data. It'll be extremely helpful for you. And when you do huge amount of data, like that's when you will really see the power of it. Oh wow, that's a lot of data, and then it's just doing it like in a few seconds. All right. Excuse me. You could still use it in full recovery model because, like I said, it's efficiently logged. So feel free to use it in full recovery model as well. Stay away. The places where you have to stay away from this hint, just because now that we know about this hint, that doesn't mean you can use it wherever you like. Please stay away from a few places. And that'll be, like I kept repeating, do not use this on OLTP highly volatile tables where the data is constantly changing. Please do not use it there because you're going to cause a lot of blocking. When concurrency is important, when multiple operations need to access the table, do not use this hint. And also, do not use it on clustered or non-clustered indexes. It will just be of no help on those tables. All right. Like I said, you can remove it, remove the indexes, do the insert, and then add the indexes back if that helps. All right. So that brings us to the end of this presentation. And these are some of the resources. The first two blocks are the ones I wrote about the insert with the tab block hint, and whatever I spoke now, it has the demos there as well. And then the three blogs are from Microsoft. They talk about these indexes and these inserts, minimal logging, and things like that. Any questions? Okay, no more questions. All right. I think it was nice talking to you all. And if you want to check out about SQL Server articles, that's my blog right there, gohi.substack.com. And then if you want to connect with me or DM me on LinkedIn about any of the questions that you have, please feel free to connect. And then that's the GitHub slide right there. Website right there where you will have the slide deck and the demo scripts, everything there. All right. Thanks, everyone. Thanks for your time and for putting up with me. All right. Thank you.
Thank you so much, Haripriya. That's a great session. And yeah, thank you so much for everyone for hanging in here. If you like the session, give a kudos to Haripriya, give a like, and share it to anybody who needs to know this information. And yes, as Veena says, this is very interesting. Thank you for joining, Veena. And yeah, so we are going to end up this session for today. And yeah, in a couple of days we'll be hosting another session. So we'll be hosting and we will be putting it online on LinkedIn about the details of it. But thank you so much. Have a great good night. It's always say I'm already ready for the weekend. Weekend, but yeah, thank you, Armando. Armando is saying it's great session. So thank you one and all for joining again, and see you soon again in the next session. Thank you.